The title of the course is Ethics and Epidemics. Perspicacious for this time of coronavirus outbreak. Now, what I had planned to do is Plan A. I had planned to compare 3 different outbreaks: the HIV/AIDS story, the Zika outbreak in Brazil, and the Ebola outbreak in Western Africa. And so we started out looking at 2 of those. We completed the unit on HIV/AIDS and the Zika outbreak. But when we were ready to start Ebola, what happened is we had this lockdown and our courses had to go online. So I moved to Plan B. And Plan B was, instead of studying Ebola, we would just use a few things from that Western African outbreak and compare it to what was evolving as a SARS-CoV-2 pandemic. So the question for the last half of the semester was, what have we learned from other viral epidemics and pandemics that we should be using to guide our response to this particular virus? As early as March 4th, scientists already knew that the spike protein of the coronavirus, SARS-CoV-2, binds to a receptor on human epithelial cells in the respiratory tree called ACE2. Well, it also turns out that cells in the lining of the intestine have this receptor. So this virus can cause a number of pathologies in addition to a respiratory set of symptoms. So how do we respond? How do we navigate a public health emergency? So social distancing is, of course, one way that we can try to keep from transmitting virus through respiratory secretions. And the purpose of this was not to make the virus go away, but to lower the number of cases so that the health system is not overwhelmed. And so the big question for us in the second half of my semester was to ask students to look at the ethical balance between public health procedures and civil liberties, people's freedom. And I serve on the ethics committee for Frederick Public Health Department. And one of the things we talked about in several conference calls very early is the lack of enough personal protective equipment. Well, it turns out that the lack of PPE was one of the hallmarks of the Ebola outbreak in Western Africa. So there are plans in place through CDC to stockpile enough of this for a national emergency. But I think because we hadn't had such an emergency, there was not as much of a national stockpile as we needed. So how do we get by if we don't have enough? Who should get them? What's the first priority? For Frederick County, we said health care workers, first line. Those who are emergency responders, people who work in aged care facilities, long-term care facilities. So highest risk, greatest threat would get first dibs on distribution of PPE. And so what do we usually do is that we try to make sure that everybody has the best treatment possible. But in a pandemic, we have to triage. Now, the gold standard for public health is what they did in South Korea, in Japan, and in Germany. Test, trace all contacts, and treat. And all three of those countries have had a regression of the number of cases and probably have the pandemic there under control. We were not prepared to have enough tests to do test, trace, treat. And that's why we ended up using social distancing and stay-at-home orders. But social justice is a hallmark of ethics, and equal distribution is important. So we read some papers about the people who are required to go to work because they're hourly wage earners. They may or may not have good health insurance. And are they therefore put at greater risk? And is that a justice problem? And it is, but what can we do about it? So if we look later, 5 years downstream, at who got sick and who died from this virus in the US, I think what we're going to see is an exposure of some social structural inequalities. That would give us a chance to think more clearly about how we prepare for future outbreaks. Now, we've seen how fast the virus can travel globally. So I think this is a wonderful invitation for us to be present and be a collaborator with our international partners on how we deal with viral outbreaks. So if and when the US gets this outbreak under control, and we will, then we also have to control it globally. So the philosopher John Rawls once said that the veil of ignorance will teach us to be fair. So we stand way back and we look at the social order. It can be our state, our county, our nation, our world. And we look at where everybody is in that social distribution. And we take this mental test. I can be anybody, anywhere in this mix. And if I really believe that, then I will make it feasible, or the least in that complex community, to have enough to live a reasonable life. And so we've seen the impact economically of forced closure as a prevention strategy. Test, trace, contacts, and treat would be a much less intrusive, less universal compromising strategy. But we would have to have enough tests, reliable tests, and a willingness to tell people who's been with you, and then be able to quarantine those individuals for a short period, 14 days, but you wouldn't have to quarantine everybody for months. So these are the things we talked about. And then students said, so where did this virus come from? Well, coronaviruses have been around a long time. They're usually resident in bats. And some scientists have studied many of these different coronavirus strains. We had an outbreak in 2003 of SARS, severe acute respiratory syndrome. And then we had an Arabian outbreak of MERS in 2012. And so this is our third SARS-like outbreak that are called zoonotic events. The virus moves from some kind of animal host, in this case bats, either through an intermediate animal and into humans, or directly into humans. And so the ability of a virus to adapt to human transmission requires some mutations. So it's been very difficult to quarantine people, especially people in elder care facilities. And so we have some lessons that we could apply as we go forward. And my students extracted from papers and read many things and wrote convincing articles so that they were very careful to say, you know, we've conquered viruses before and we will again, but what we need to avoid, and one of the things we learned from studying HIV/AIDS, is that we should not blame the people who get infected. So this virus is now well characterized. The genome is sequenced. We know this surface protein S is what antibodies bind to keep people from getting infected. So many companies, about 100 different trial vaccines are now being tested, and they use one of three strategies: whole virus, attenuated so it can't hurt you; subunit, where you put just the gene for the S protein and express it; or RNA or DNA vaccine. So what did we learn from testing vaccines in the middle of Ebola or Zika outbreak? What risk would you take? Would you rush approval? How do you balance risk and benefits? So I asked them to write their final paper on a couple of things, and some of them chose to write about, if we have a vaccine, will it be mandatory or voluntary? And then another group wrote that we should have a challenge trial where healthy people take the vaccine and then are exposed to the virus, as opposed to vaccinating a lot of people in a hot zone and just letting them go about natural exposure. So I'd like to ask you what your questions are, or comments, or anything you want to ask me, or what you want to say, or something more you want to learn from this session.
And please feel free to unmute yourselves, and you can vocally ask your questions, or you can type them into the chat as well.
Hi.
We have a question from Catherine. How are vaccines tested?
Okay, generally, the gold standard is we take the vaccine and we inoculate 10 to 20 people with different doses. And that's to determine that it's safe, that there's no negative reaction, and that people make antibody against a certain dose. And so then we go to a larger number of people, 100, 200 people, and they're divided into two groups, those that get the vaccine and those that don't. And then they go about their business, and we track them for about 6 to 12 months. We take serum to make sure they have antibody if they got the vaccine. And then they are free to move around with people who are, for example, sick. And so good group to sometimes volunteer for this stage of testing are doctors that are caring for these patients who have the virus. So we know they're going to be exposed. And then the statistics tell us that the people with the vaccine don't get sick, and the people without the vaccine do, that it's protective. And then we do that in a much larger group of several thousand people, just to be sure there's no variation by ethnicity, age, gender, other variables. So that's how we usually go about it, and it takes about a year to go through all three stages. Now, in outbreaks like the Ebola outbreak in Western Africa, they took a trial vaccine that is called the animal rule. It was protective in animals, and so they let them try it in the medical workers that were taking care of Ebola sick people and the immediate family members. And so they called it a ring vaccination. It's like the idea of contact tracing. So the people that were exposed got the vaccine. Now you don't know how long it takes to develop protective immunity. Usually that's about a 6-week window. So it was hard to interpret the data, but then they would go out to other people distant from the immediate contacts and vaccinate them. And they were able to get data that showed that people were protected. And so now that vaccine has been approved by FDA. There's a new Ebola vaccine because they went into that epidemic and were able to do those tests successfully.
Dr. Boyd, hi, Kathy Manning here.
Hi, Kathy Manning.
Good to see
Good
you.
to see you again. How are you?
I'm good. I'm doing really well, doing research and stuff.
Where are you working?
I'm at Brigham and Women's Hospital, Harvard
Yes,
School of Medicine.
I know it well.
Yeah. Yeah, my question was actually about with the vaccines that they're working on, how are they going to know about how long those are efficacious for? Like, it's like the seasonal flu, you got to get it every year, but like, measles, it's one and done. So how do they test that?
Okay, so that's a great question. You probably know that some of our vaccines are lifelong protection. Some last about 10 years, and some, like the influenza vaccine, about a year. So there's something called immunological memory. And the big challenge for us is antibody is neutralizing, but it doesn't last long. And so if the vaccine only stimulates antibody, then it'll probably have to be boosted to be protective. But if it stimulates the T cell memory, CTL response, for clearance, it lasts much longer. So we need vaccines that both trigger antibody and T cell responses to get long-lasting protective immunity. So that's number one. Number two, we don't know how fast this virus is mutating, but we know that it's an RNA virus, so its mutation rate will be quite high. And so the question is, if we make antibody against the S protein now, will it just what we call immune escape? Will it make a mutation and go around that? That's the problem with influenza. It mutates so fast that we have to capture new strains and make new antibody producing antigens every year.
Do they have any indication of how quickly this one is mutating, or no?
Well, there are some, okay, so there's some really fancy molecular virology going on right now, and sequencing these viruses is much easier than it's ever been. In next-gen sequencing, we can do the whole genome. So there are already mutations mapped in the S region just during this outbreak, right? So, the influenza 1918 pandemic had a curve very much like the one we're in now, and then it went down, and then the following year it came back, and the population of people that were infected in the second wave were younger, more healthy than the people who seemed to succumb to it in the first wave. So they have tracked back and been able to show that the virus did mutate and become a little bit different virulence in the second wave. And that could happen with this virus as well.
Thank you.
Yeah. Hi, how are you?
I'm good. How are you?
I'm good.
Question for you following on to the vaccine piece because of the mutation rate. So, there's 5 different kinds of vaccines in development. Thoughts on which one has a higher probability? I mean, looking through the the crystal ball, but advantages over DNA, RNA vaccine in this particular situation. What do you think?
Well, what I think is that we're just now beginning to really appreciate how nucleic acid vaccines work. They're easy to make, easy to amplify, and modify. And so if they have good, if they stimulate good immune response, they'll be the easiest to do. Now, my personal favorite is the recombinant vaccine. I like the vesicular stomatitis virus because it has no pathology in humans.
Mhm.
And so we have that genome, we know how to flip out one gene and put in another. And so my money would go for VSV, take out a gene, put in S, and give that as an injection, because VSV does replicate, but it would express that surface protein, and we should get a full-blown antibody and T-cell response. That's what I think. Now, I know the Chinese have already raced ahead and made an attenuated vaccine of the real virus. And they have a clinical trial going on right now with an attenuated SARS-CoV-2.
Is it intranasal?
Yes, yes. Hi.
And we have time for about one more question before we need to start our next session. So any final questions for Dr. Boyd?
It's good to see you guys.
Oh, it's great seeing you too, Dr. Boyd.
Thanks for doing this. This was awesome.
Yes, thank
Thank
you.
you to Dr.
much.
Boyd. Our next session will be beginning momentarily with Dr. Moore and Dr. Greikis, and it is on how pandemics heighten social inequalities, already existing inequalities. And in the chat, I typed the link that you can follow. Thanks,
Thank you.
everyone.
Thank you very